All right, hitting the ground running on a Monday. Mrs. Lincoln's 4th, 5th, and 6th grade class are actually going to be listening in on this. So say hello, Mrs. Lincoln's class.
Hello, Mrs. Lincoln's class.
All right, yeah, okay. There you go. Any problems downloading 4.4? Does the bandwidth work okay on a Monday morning? Sometimes that's not an issue. Sometimes it is. Okay, so we just studied logs, and now we're going to study properties of logs. What can you do with logs? Remember the log in general. Yes? If we finish today, it will be due tomorrow. So you'll have a little bit of homework today. Yes, good question. Logs are nothing more than a what? A what-ponent? An exponent. That doesn't mean a former ponent, right? It means an exponent. It's a power. And so what they do is they make molehills out of mountains. They take big numbers and make them manageable, remember, astronomically big. And then they take microscopically small and bring them up to workable scale. All right, so if you know the rules of exponents, you will understand clearly the rules or the properties of logs. So here's property number 1. And we spent a lot of time in the beginning of the year going over this. When you are multiplying and the bases are the same, you do what with the exponents? Adam? What do you do with the exponents, Adam? No, when you're multiplying, you add them. Adam, yes. Okay, so multiplication turns into addition, right? Multiplication turns into addition. That's the same thing with logs. Log of the product of two things, doesn't matter if it's ln or base 10 or base 5, whatever. The log of a product is equal to the sum of the logs. So just like with exponents, it takes a multiplicative process and turns it into addition. So if you ever have the natural log of a times b, each factor gets its own log, and you add them together. Okay? Did y'all get this in Algebra 2? Some people did, maybe some people didn't. Okay, let's try it out. Example 1, the natural log of 3 times 5. Well, we know that's the natural log of 15, right? Well, guess what else it's equal to? It's equal to the natural log of 3 plus the natural log of 5. Pretty easy, right? You have two factors, 3 and 5, so you're going to have two terms. They each get their own log, and you add them. Now, we better verify that before we go on, because y'all are in the habit of distrusting me somewhat, which is good. A healthy skepticism is good. Let's try it out. Natural log of 15. 2.708. Is that a reasonable answer? Oh, yeah, more than reasonable. It's exact. Let's try it the other way. The natural log of 3, just got to close the parentheses, plus the natural log of 5. If we don't get the same answer, then we quit learning for the rest of the year. Agree? All right. We get to keep learning. Yay. Yay, we get to keep learning. That's awesome. Okay, so we just verified that the property works. So working with numbers is fine, but typically we're going to work with variables. So here we have the natural log of 4xy. How many factors do we have in our argument? How many factors do you see there? I put parentheses around it. 3, right? A 4, an x, and a y, 3 factors. So when you expand it, guess how many terms you're going to have? 3, very good. Yeah, it's not a trick question. This becomes the natural log of 4 plus the natural log of x plus the natural log of y. Pretty easy, right? Every factor gets its own log and you add them together. So whenever you move from the left side to the right side, this is called expanding. Right? We're expanding it. We're making products that could potentially be really, really large, and we're turning them into sums, which is a lot easier to work with. But these things are identities, so they work both ways. If you started with something on the right, and I ask you to put it in the form on the left, that's called condensing. So you got expanding and condensing. The two examples we just did, we expanded. So let's look at example C. You have the natural log of 4x plus the natural log of 3x plus the natural log of 2. Is this one completely expanded? It's not completely expanded, no, because notice the first term can be expanded further as the natural log of 4 plus the natural log of x in the second term as well. But it doesn't need to be completely expanded to condense it. So we want to condense it. So how many terms do we have with logs? 3, right? So when we condense it, how many factors are we going to have, or factor groups? Also 3. Yeah, again, not a trick question. So when you condense, what you do is you pull one log out front. And because all of these terms are positive, we do what with their arguments? Well, they're currently added, so when we condense it, we multiply the arguments. Yeah, so put a big parentheses up there, and you get 4x times 3x times 2. That's condensing it. It's just going the other direction. Of course, now you can simplify that. That's the natural log of, if you multiply all the numbers together, you get 12 times 2 is 24, x times x is x squared. And you're done. It's like playing an accordion, right? Expanding, condensing, expanding, condensing, expanding, condensing. All right, so there's 3 examples from property 1. Products turn into sums, right? And it comes from this rule of exponents. Let's jump to property number 2, and we'll look at the exponential rule first. When you're dividing and the bases are the same, what do we know to do with the exponents? We subtract, yeah. So a division process turns into subtraction when you do the rules of exponents. It's the same thing with logs, all right? If you have the natural log or the log base 10 or any log of a quotient, a divided by b, it turns into subtraction. The natural log of a, in this case, minus the natural log of b. So the numerator's argument is the positive term, and the denominator's argument is the negative term. Top is positive, bottom is negative, all right? So the natural log of a divided by b is natural log of a minus natural log of b. Same thing, if you go from left to right, you're expanding. If you go from right to left, you're condensing. All right, let's try it out. The natural log of 4/3. That should equal what if we expand it? Natural log of 4 minus natural log of 3? That's exactly right. Easy. Easy, easy, easy. All right, so now this one. This one has 2 factors in the denominator. So if you want to do this one in multiple steps, here's what it would look like. Natural log of 7, that's positive because 7 is in the numerator, and then minus the natural log of the quantity 6x, like that. Now that is not completely expanded. So if it says to expand, you want to completely expand it. We can actually expand the second term even more. Now you got to be careful when you're expanding behind a negative sign. You need parentheses because you're going to turn it into 2 terms. That becomes the natural log of 6 plus the natural log of x, right? Because we're multiplying 6 times x, so it becomes natural log of 6 plus the natural log of x. But because they were behind a negative sign, we now have to distribute, and we get minus the natural log of 6 minus the natural log of x. And so I want you to be able to go straight to the final answer in one step without having to put the parentheses. So here's how you could do it. Any factor in the numerator is going to get a positive term. And any factor in the denominator is going to get a what? A negative, right? Any factor in the top gets its own log with a plus sign in front of it, and any factor in the denominator gets its own log with a minus sign. That makes it real easy to expand in one fell swoop. So let's put a bonus one in here. Let's call this bonus 1c. Let's say the natural log of 5xy over 3zp. I'm just making up letters. 5xy over 3zp. Go ahead and expand that one completely and see if you can do it in one step. You have 6 factors total, 3 in the top, 3 in the denominator. So that is going to end up being 6 terms, each with their own natural log. Plus signs and minus signs. Plus signs and minus signs. You don't have a denominator anymore. When you expand it out, you just have a list of terms. All right, let's see how y'all did this. The top, 5xy, they all get plus signs. So it's the natural log of 5 plus the natural log of x plus the natural log of y. That's expanding the numerator. 3 factors, all positive because they're in the top. Now you have 3 factors in the bottom, and they're all negative. So then minus the natural log of 3 minus the natural log of z minus the natural log of p. And you're done. That's it. I had 6 factors to start with. I have 6 terms to end with, each with their own natural log. A factor in the top gets a positive term. A factor in the denominator gets a, what type of term? Negative, yeah. All right, pretty easy, right? So that's called expanding. We're going to go from left to right. Now we can condense. We can condense. How many terms do we have there? 3, right? 3 terms. So how many factor groups should we have when we condense? Same number of 3. So to condense, since you have 3 terms, they're all natural log, you pull the natural log out. Now, all 3 of those terms are negative, so where are the arguments going to be multiplied, in the top or the bottom? They'll be all multiplied in the bottom. Yeah. So we need to create a denominator. So I'll just create a denominator by building a shelf. And in the denominator, then, we'll have a 3 times an x times a 5x. So what goes in the numerator? A 1. Excellent. Very good. Okay. Why 1? Did you guess correctly, or you knew it, or both? Can I just say plus the natural log of 1 there and have the same thing? Is that equivalent still? What is the natural log of 1? 0, right? What's log base 10 of 1? 0. What's log base b of 1? Yeah, it's 0. Remember, we talked about that in the previous section. Every graph of the form log base b of x is going to pass through 1, 0. It's the x-intercept. So it's like adding a 0 at the end of an expression, which, of course, doesn't change its value. And so now if you wanted to condense that, because it's plus, it's going to be multiplied in the numerator, and the argument is 1, so it goes in the top. All right? Now you can simplify. Since you've got it condensed, you can start combining like factors in the denominator. You got a 3 and a 5, that's a 15, and you got an x squared. So there is the simplified condensed version. And again, notice to start with, it wasn't completely expanded, which is fine. When it says condense, you want to condense completely. When it says expand, you want to expand completely. All right, to review the 2 properties. Multiplication turns into addition, and division turns into subtraction. The last property is my favorite. If I were to have a favorite, it would be property number 3. All right, so let's look at the exponential rule. When you raise a power to a power, that's exponentiation, right? What do we do with the bases when we're raising a power to a power? We multiply them, right? So exponentiation turns into multiplication. So logs take everything down 1 rung on the operational ladder. Multiplication turns into addition. Division turns into subtraction. And now exponentiation comes down 1 rung to multiplication. When you raise a power to power, you multiply. It works out the same way when you have logs. Logs are just exponents. So notice the natural log of a raised to the power of b. That's exponentiation. It turns into b times the natural log of a. It turns into multiplication. So the reason it's my favorite is because what you're essentially doing is you're bringing the exponent on the argument out front, and you turn it into multiplication. So when you go from left to right, again, that's called expanding. And if you were to go from right to left, again, that's called condensing. So you could bring exponents on the arguments out front, or if you ever see something out front of a log, you could bring it back up as an exponent on the argument. It works both ways. It's an identity, we say. All right, let's try it out. We got the natural log of 2 cubed. That's, of course, the same as the natural log of 8. But if we use the property that we just learned, what can I do with the 3? Bring it out front. That's the same as 3 times the natural log of 2. They're one and the same. So if you are working a problem and you end up with the natural log of 8 as an answer on a multiple choice question, I would probably not type it up as natural log of 8. I would type it up as 3 natural log of 2. Okay? It forces you to do a little extra step. The natural log of 8 is the same as 2 to the third. You could bring a 3 out front. So notice what it does again. It makes a molehill out of a mountain. It takes this gigantic number of 8, right? Almost uncomfortably large, right? And it turns it into a 2 with a little multiplicative constant out front of 3. Pretty easy. All right, you do this one on your own. Natural log of x squared. I know you're done. What'd you get? 2ln of x. Perfect. Yeah. Remember, when you work straight down with an expression, you really don't even need the equal sign. Natural log of x squared is the same as 2ln of x. All right, so that's expanding. Let me give you a bonus one right here. Let's call this B2. B2. Let's switch bases here, because it works for any base. Let's do log of 2x quantity cubed. All right, I see most of y'all are done. Since the entire argument is to the third power, you can write that as 3 log of 2x. Now, is that completely expanded? No, now I can expand that more because now I have a product. And here's where you have to be careful. That 3 is multiplied by the entire log, which is about to become 2 terms. So then you would write that as parentheses log 2 plus log x. Or if you wanted to distribute it, 3 log 2 plus 3 log x. And that would be the full expansion right here on the bottom line. So now notice there's another way to get there. If you didn't want to do it that way, you can actually use your properties of exponents. 2x quantity cubed, remember, is the same as 2 cubed x cubed, right? If you have a product raised to a power, you can multiply the exponent by the exponents of each factor inside. And now you can expand this. It's a product first, so that would be log of 2 cubed plus log of x cubed. And then on each of them, you could bring the 3 out front. 3 log base 10 of 2 plus 3 log base 10 of x. And that's the exact same answer we got right there. So just like with the exponents, there's certain sequences you could take, and as long as you're not breaking any of those rules, you're going to get the same answer in the end. All right, let's call this one B3, bonus example 3. What if I have log, let's make it base 5 now, of 2x cubed, like that. Aside from it being base 5 instead of base 10, notice the difference this time on the argument from the previous example is it's not the entire argument cubed. Can you then just bring the 3 out front, I'll put a question mark there, and call it 3 log base 5 of 2x? Does that work? Why not? That's right, it does not work. This is not equal. Right, the 2 is raised to the first power, right? It's only the x in this case that's raised to the third power. So you can't bring the 3 out front unless it was the quantity cubed. All right? So that's the previous example. The whole quantity was cubed. So in this case, bringing the 3 out front would not be the first way to go. The first thing you would want to do if you're expanding it is to think of it as a product. Log base 5 of 2 plus log base 5 of x cubed. And now, on the second term only, you could bring the 3 out front. So you got to be careful, right? Of course, we know to be careful all the time. Inch by inch, it's a cinch. So one piece at a time. Parentheses, grouping symbols, They address the priority of the operation. Okay, so now we'll go to part C, condense. 2 natural log of x plus 2 natural log of 3 minus 4 natural log of y. This one is completely expanded. We want to condense it down to a single natural log. So first thing you want to notice is that there's 3 terms. With 3 terms, there'll be how many factors? 3. You'll always have the same number of factors as you have terms. 2 of them are positive terms, right? The first 2 are positive. That's an implied plus sign in the front. So those 2 arguments are going to be multiplied in the where? Numerator or denominator? Numerator. And one of them, oops, not the highlighter, one of them is negative. So that argument's going to be multiplied in the denominator. Okay, so I'll have 2 factors in the top, 1 in the bottom. But we can't condense right away, simply because we have coefficients in front of the logs. So the first thing you want to do when you're condensing is to make the coefficient of each log term either a 1 or a negative 1. You want to make the coefficient either a 1 or a negative 1. Because once you have that, then you can start condensing like in the property 1 and 2. All right, so step 1, I'm going to bring the 2 up as an exponent, the 2 up as an exponent, and the 4 up as an exponent on the entire argument. So that becomes the natural log of x squared plus the natural log of 3 squared minus, we'll just bring up the 4 and we'll leave it negative, the natural log of y to the 4th. So the last thing you would do when you're expanding is to pull the exponents out front. The first thing you do when you're condensing is put the exponents back up. You're doing kind of the reverse order when you go backwards. All right, now since I have coefficients of 1 and negative 1, now I could pull a single natural log out. And because you have at least one negative term, you know you're going to have a denominator. So go ahead and build a shelf. If you have at least one negative term, you're going to have a denominator, so build the shelf. Now it's as easy as just putting the arguments on the right shelf, either the top shelf or the bottom shelf. The 2 positive terms arguments are x squared and 3 squared. So they get multiplied on the top shelf. And the negative terms argument, y to the 4th, gets multiplied in the denominator. And once you condense, then you can start simplifying what the argument is, like we did at the beginning of the year. So this then turns out to be the natural log of, we'll put the number first, 3 squared is 9. And then we typically write things in alphabetical order. So there it is condensed. The natural log of 9x squared over y to the 4th is equivalent to what we started with. So again, you're like playing an accordion. Expanding, condensing, expanding, condensing. They're equivalent expressions to each other. All right, so there you go. 3 properties. That's all you have to memorize, those 3 things. And they are profoundly important. What's that? Oh, we missed D. He's hiding there amidst all the clutter. Okay. It says to condense. What does that mean? How do we do that? Well, we have e raised to the 2 natural log of x. This is like a little problem inside of a problem. The exponent is 2 natural log of x. We can condense that. So pretend like you're just working upstairs. What would 2 ln of x condense to? ln of x squared. Good. You could bring the 2 back up as an exponent on that argument. And now we can simplify from the previous section. What is e to the natural log of log? Remember, this is the same as e to the log base e of x squared. That's what natural log is. It should be what? It should be x squared, right? Yeah. So e to the 2 natural log of x is just x squared in disguise. So that was the properties we talked about in the previous section. Let's kind of rewrite them. It's worth doing. B to the log base b of x is equal to x, which is the same as log base b of b to the x. That was from the previous section, and that's also hugely important. That's because logging base b and exponentiating base b are related how? They're inverses of each other. So this is composing them back to back. So we used a little bit of both things right there. We condensed first, and then we used the inverse nature of natural log in e to just reduce it down to the exponent. But you couldn't do that until you condensed the numerator. Okay? All right, if you go on to take calculus, which many of y'all will, we use these three properties of logs quite a bit. We have a motto in calculus. It's called simplify early and often, comma, especially when you have logs. Especially when you have logs, look to simplify. Because logs make molehills out of mountains. They make things more manageable. They turn products into sums, quotients into differences, and then they turn exponentiation into multiplication. All right, so example 4 is kind of nice. I'm not going to have you prove anything on a test, but it's kind of interesting. Prove property 2 and property 3 using the other properties of logs. So property 2 was this one. That was the one that was said the natural log of A divided by B is equal to the natural log of A minus the natural log of B. All right, so the rules of proof are basically start with one side, try to make it look like the other. And if you do it with variables instead of numbers, you show that it's true for all values. Now, if this is property 2, that's the only property I can't use. You can't use the property itself to prove itself. Okay? That's like defining a word with the word itself. What is a dog? Well, a dog, of course, is a dog. Thanks. That didn't help me at all. I don't know what a dog is. That's why I asked. All right? So that means I can use property 1 and property 3. So here's what I'm going to do first. I am going to rewrite my argument as A divided by B. I'm going to rewrite it as A times B to the negative first. Is that good? Is that equivalent? Yeah, sure it is. Now I have a product. So I can use property 1. That becomes the natural log of A plus the natural log of B to the negative first. And now I can use property 3 on the second term. That becomes the natural log of A. And where can that negative 1 slide? To the front, making it minus natural log of B. And if you notice, the left side now looks like the right side. Sometimes we'll draw a line down the middle, and when we're done with the proof, we like to get all fancy in Latin. We typically put QED on the bottom right. When you got the bottom left to equal the top right, QED. Does anyone know what that means? If you did geometry proofs back in geometry, maybe it showed up. It's Latin. It's quid erat demonstratum, which means that which has been demonstrated. It's basically a fancy way to say, we're done. We're done. Yeah. All right, it also says to prove property 3. So let's go ahead and revisit property 3. That was my favorite one, remember? That was the natural log of A to the Bth power equals B times the natural log of A. So I can use property 1 and property 2 and any other thing except property 3. All right, so I'm going to work on the left side. I'll draw the line first. What does the natural log of A to the Bth power actually mean? Well, it means, because B is the exponent, it means that I have A times A times A times A how many times? B times, right? 2 cubed is 2 times 2 times 2. The B tells you how many factors of A you have. So I can write the natural log of A to the Bth power as natural log of A B times. That's not using either one of the properties. That's just exponents, definition of exponents. But now I can use property 1 because now I have multiple factors. I can write that as the natural log of A plus the natural log of A plus dot, 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 the natural log of A. And how many of those will I have? I should have as many of those as I had A's, right? I had B A's to begin with, so now I'm going to have B terms with the natural log of A in it. And isn't abbreviated addition known as multiplication? What is 3 plus 3 plus 3? Well, it's 3 times 3. What's 3 times 3 times 3 times 3? That's 4 times 3. So if I'm adding up the natural log of A, B times, that's the same as B times the natural log of A. And if you compare that to the right-hand side, we're done. They look exactly the same. So QED, quid erat demonstratum. So the properties work. That's what I'm getting at. We verified on the calculator. We just proved them. They work. And they are so useful when you have expressions involving logs. Hi, Coach Fair. Thumbs up. Moses agrees. All right, so example 5. It says to expand in one fell swoop. Not two fell swoops, one fell swoop. One of the most dangerous things to do is to try to leap over a chasm in 2 leaps. Yeah, we're not going to do that. We're going to jump all the way across, all right? This is where I want you to be. I want you to be able to look at something like that, and ultimately, after you practice on the worksheet, be able to expand it in one line only. Now, in order to help ourselves, I am going to take one line of liberty to rewrite the radicals as rational exponents, okay? If you ever have any radicals, you want to write them as rational exponents. So here we go. This is log base 7. And in the top, we have a 5 times an x squared. I'm putting a little dot in between them just to show separation. And that's going to be 2y minus 1 to the what power? When you get rid of the cube root, it becomes 1/3 power, right? So if it's squared to the 1/3 power, that becomes to the 2/3 power. And again, that's stuff we did at the beginning of the year, so that shouldn't be new to you. In the bottom, I have 2 times y times x plus 1 to what power? If it's the square root. 1/2 power. Good. All right, so at some point, you wouldn't even need to do that because you could think about each of those factors with the radical in your head. All right, so how many factors total do I have? Let's count them. I got 1, 2, 3 factors in the top, and 1, 2, 3 factors in the bottom. So when I expand it out, I'm going to have 6 terms. 3 of them are going to be positive log base 7s from the 3 factors in the numerator, and 3 of them are going to be minus log base 7s for the ones in the denominator. And as we write it down, where do the exponents go? What's the last thing we could do? If you have an exponent on the argument, it can come out front, right? So let's do that in one fell swoop. Here we go. Start a little bit to the left here. We have log base 7 of the first factor in the numerator is 5. So we get log base 7 of 5. Almost like a little round of applause for that. Yay. Plus, leave a little space after the plus sign, because now you have log base 7 of x squared. But guess where the 2 can go? Oh, I took too much. Into the front. It's cool. You can animate with notability. So you don't actually have to write it with the x squared up there. You can just put the 2 in the front as you write it down from left to right. On the next term, what goes in front ultimately? The 2/3 exponent, right? 2/3 log base 7 of 2y minus 1. So there takes care of the numerator. I need to remodel. I need to move that over even more. So there's your 3 plus terms. Those are positive because they came from factors in the numerator. They all get their own log. Now we have 3 factors in the denominator, so now it's going to be minus. So now minus log base 7 of the first factor in the denominator is 2. Minus the next factor, log base 7 of y. And then finally the last one, minus what can come out front? The exponent of the 1/2 will ultimately come out front. So you can write it as 1/2 log base 7 of the quantity x plus 1. And there it is. You have successfully expanded it in one line. Every factor got its own law. Numerator's got plus signs, denominator got minus signs, and any exponent made its way out front of that particular term. Now, question. Can you then take some of these terms that have 2-termed arguments, can you distribute the log inside? Can we do that? Because I see some people kind of wanting to do that. Well, let's see. Is it true that the natural log of a plus b is equal to the natural log of a plus the natural log of b? Have we ever learned anything like that? The log of a sum is the sum of the logs? No, that's not true. That is not true. Because remember, the natural log of a plus the natural log of b is equal to the natural log of a times b. Products become sums. So you cannot distribute a natural log inside its own argument. You cannot do that. It does not work. So you are essentially done right here. If you have the log of something with multiple terms, it's done. Okay? You can make factors into terms, though. All right. Let's look at example 6. We're going backwards now. Now, it says to condense in multiple fell swoops. It's going to be a little bit harder to condense down in one fell swoop, especially if it's not completely expanded to begin with. All right, so let's go through and take inventory. We got 1, 2, 3, 4. I've got 4 terms. See that? 4 natural logs. So ultimately, I'm going to have 4 factors. I'm going to have a natural log out front and 4 factors. The first thing you want to do, remember, when you're condensing, is to make sure your coefficients, which will become exponents, are either a 1 or a -1. And I noticed that 3 of the 4 are not 1 or -1. So step 1 is bring those exponents back up on the argument. So leave the negatives in front. If they're negative, leave it there. This becomes negative natural log of 2 cubed minus the natural log of x to the 1/2 plus the natural log of the quantity 3x squared. And then the last one was all ready to go, natural log of 2y squared. So that's step 1. If the last thing we did when we expanded was to bring the exponents out front, the first thing we do when we're condensing is to bring the exponents from, or the coefficients from up front back up as exponents. Now we're ready to condense. So now pull 1 natural log out front. You have 4 terms, 2 of them are negative, 2 of them are positive. If you ever have at least 1 negative term, you know you're going to have a denominator. So go ahead and build the shelf. It's a lot easier to put things on the shelf once the shelf is built. Have you ever tried putting like a glass object on a shelf that's not there? What happens when you let go? Oh, it breaks. Okay, good thing we built the shelf first. All right, so if I go from left to right, those 2 arguments came from negative terms. So they get multiplied where? Top or bottom? Bottom. Good. So this is going to be a 2 cubed times an x to the 1/2. They turn into multiplication in the denominator. The other 2 terms are positive, so they get multiplied in the numerator. And be careful, this is still the quantity 3x squared and then times 2y squared. And you've essentially condensed it. It took 2 lines to do that instead of 1. Now all you have to focus on is simplifying this. And that takes you back to what we did at the beginning of the year. We worked lots of problems like that didn't have natural logs in front. So let's go ahead and start simplifying that. You get 3x quantity squared, that's the same as 3 squared, which is 9, times x squared, times the 2y squared that's there. So that's the top. And then the bottom 2 cubed is 8, that's x to the 1/2. And now we could start combining from high to low. Look at the numbers first. You've got a 2 and an 8. Those divide out to give you what? 1/4, right? So you're left with a 9 in the top and a 4 in the bottom. 9 times 2 is 18/8. If you rather do that, 18/8 simplifies down to 9/4. So that takes care of your numbers. If that were like 8/4 now, we would just call it 2. But 9 and 4 are co-prime. Remember co-prime? They don't have any common factors other than 1 or -1. All right, so now we'll focus on the x's. And look at this. We've got an x factor in the top and an x factor in the bottom. So when we are dividing, what do we do with the exponents? We still subtract them. Yeah, what's 2 minus 1/2? How many halves is that? 3 halves. Good. So we get x to the 3 halves in the top. And that takes care of the x's. And we're just left with y squared. There's no y's to simplify it with. So there's your answer. Natural log of 9x to the 3 halves y squared. You could write that a little bit prettier now, if you wanted to, as 9/4 x to the 3 halves y squared. Because the only thing in the denominator was a number, you could actually write 9/4 as the coefficient. All right, so that makes a great multiple choice question on a test. Which of the following, it would say, is equal to this when condensed? And here's the answer choice I would more than likely type. Inch by inch, it's a cinch when you're condensing. First step, bring your coefficients back up as exponents. Then go ahead and pull the log out. Build the shelf if you have a negative terms, and you're either multiplying in the top or the bottom. All right, let's use these properties now to evaluate these things. Log base 4 of 2 plus log base 4 of 32. Notice there are no variables here. That's a number. It's equal to something. It's equal to something. We want to know what it's equal to. So here's what we're going to do. If I look at the logs, they're both base 4. That's good. If I can make the arguments the same, we have like logs. Okay, like terms. If you have log base b of x, 2 of them, plus 3 log base b of x, in algebra we call these like terms because the variable part is exactly the same. So what is 2 of those plus 3 of those? You have 2 of them in one hand, 3 of them in the other, you have a total of 5. So that's what our goal is. If we can make the arguments the same, then we can start combining like terms, like logs. So log base 4 of 2, I think, is pretty stripped down. It's pretty easy. But if I can write 32 in terms of 2, that'd be great, which I think I know how to do that. So that's log base 4 of 2. We're going to leave that alone. This becomes log base 4 of 2 to the what power? 32 is a power of 2. It's 2 to the 5th power. Good. 2 to the 5th power or 5th power. Now we can use property 3 on the log to do what with that 5 on the next line? We can slide them out front. So we get log base 4 of 2 plus 5 log base 4 of 2. And now we have like terms. I have log base 4 of 2, log base 4 of 2, 5 of them on the right plus 1 more here. That's an implied 1, remember. What's 5 plus 1? 6. 6. So we get 6 log base 4 of 2. Now that might be a good place to stop. It looks less complicated because we only have 1 log instead of 2, but I think we could keep going. Can we write 2 as a power of 4? This is what we did in the previous section. I can write 2 as a power of the base. It's the same as 4 to the 1/2 power, right? Because 4 to the 1/2 is the square root of 4. And now we can use the property from last time. What is log base b of b to the 1/2? Log base 4 of 4 to the blob is just the blob. Because remember, they're inverses. You're starting with a 1/2, you're exponentiating base 4, then you're logging it as base 4, they'll go away. So you're left with 6 times a 1/2, also known as what? 3. So what do you know? This thing right here, this original expression, was just 3 in disguise. That's pretty awesome. Log base 4 of 2 plus log base 4 of 32 is a crowd, they say. That's how the saying goes. All right, let's try this one here. We got log base 2 of 80 minus log base 2 of 5. Now, if you notice on the last term, 5 is prime. We're not going to be able to write 5 as a power of 2. So I don't think we're going to be able to get off so lucky on this one. But I can perhaps write 80 as a factor of 5 times something, right? I know that it's divisible by 5 because it ends in 0. So let's go ahead and see if we could do that. 80 is the same as 5 times what? 5 goes into 8 once, with 3 left over. 5 goes into 30 16 times. So that's not a bad start, right? I didn't write 80 as a power of 5, but I wrote it with 5 as one of its factors. Now, what can we do with this right here? I have the log of a product. That turns into the sum of the logs. So that becomes log base 2 of 5 plus log base 2 of 16. And then I'll just bring down that other term. Holy moly, smokers. Anybody notice something cool on this line? Now that we've expanded the first term, I have a log base 2 of 5 over here and minus the log base 2 of 5 over there. What happens to those? They cancel. And we're left with log base 2 of 16. Now I can focus on log base 2 of 16. Can I write 16 as a power of 2? Yeah, it's 2 to the 4th power. And now, what is log base 2 of 2 to the 4th? Should be 4. That's using the inverse property of logs. So A was really 3 in disguise. B was actually 4 in disguise. If we had a C example, it would probably be equal to 5. Maybe not. I don't think it works that way. Now, that's just one way to do it. Remember the calculus motto, which could be Precal's model as well. Motto, simplify early and often, comma, especially when you have logs. If you don't want to write 80 as the power of 5, could we condense this first? Yes, you can. You have log base 2. So notice, since the log base 2 of 80 is a positive term, the argument 80 gets multiplied in the numerator, and the 5 comes from the negative term, so its factor gets put in the denominator. So that's another first move that you could have done. It almost makes it a little bit easier, because now you can simplify this. What's 80 divided by 5? 16. And now you're kind of at the same point we were over there. That's the same as log base 2 of 2 to the 4th, and you're just left with 4. All right, you could have done the same thing over here. Log base 2 of 4 plus log base 4 of 32. You could have combined those, log base 4 of 64. And then you can write 64 as 4 to the 3rd. So lots of different ways to work towards the right answer. It's just a matter of what you see. So how do you guarantee that you see a lot of problems so that you can be efficient when you're faced with something like this? You practice a lot of problems, okay? And you'll find those in the worksheet. So I think I'm going to stop here for today. We'll finish up pretty easily tomorrow. So the worksheet is not going to be due tomorrow, but it will be due on Wednesday. And we're going to finish these notes tomorrow and roll right into 4.5. 4.5 uses those 3 properties to solve equations, all right? So we'll pick up with these common errors tomorrow. Don't forget, your Christmas ornament is due tomorrow. Mrs. Lincoln's class is